in chapter 8, we're going to talk about different polygons. And y'all remember a polygon is just a multiple-sided figure. What's the smallest polygon you can have? A triangle, because you have to have at least 3 sides to connect together, okay? So triangles are our smallest polygons. We have spent the last 3 chapters or so talking about triangles, okay? We've about triangled ourselves to death. Well, triangles are not the only polygons, okay? What is a 4-sided figure called? Quadrilateral. What's a 5-sided figure called? What about 6 sides? 7 sides? 8 sides? 9 sides? 10 sides? 11 sides? 11 gone, right? If it doesn't have a name, you just say the number of sides it has with the word gone on the end of it. What's a 12-sided figure?
It's
Dodecagon, right? And 13 sides is just a 13 gone, and so forth from there, just whatever number gone it is. All right, so we're going to be talking a lot about different polygons, especially quadrilaterals for the rest of the chapter. So the first part we need to talk about is what a diagonal is. A diagonal goes from one corner of a polygon to the other side, okay? It goes through 2 vertices. All right, and it says non-consecutive. What does that mean, non-consecutive? Not coming right after each other, okay? All right, so this is a theorem that you need to know, or at least you need to know the formula to it, and that's the polygon interior angles theorem. It says to find the measures of the interior angles of a convex n-gon will be n minus 2 times 180, and n is the number of sides. So, for example, how many sides does a triangle have? 3. 3 minus 2 is what? 1. 1 times 180 is what? 180. What's the interior angles of a triangle add to be? 180. 180 degrees. So what do you think it would be for a quadrilateral? How many sides does a quadrilateral have? 4 minus 2 is 2 times 180 is 360. So what if it asks for a pentagon? How would you do that? 5 minus 2 is what? 3, so it'd be 3 times 180. What about an octagon? 6 times 180, right? Y'all see what I'm going there? What about a 15-sided figure? What would it be? 15 minus 2 is 13 times 180. So however many sides it is, you subtract 2 and multiply that number times 180 to say what the interior angles of that polygon will add up to be. Okay? All right. So that is the interior angles theorem. Now let's talk about for a quadrilateral. Now this is called a corollary because it is derived from a theorem. The previous theorem said n minus 2 times 180 will be for any polygon. Therefore, for a quadrilateral, that comes out to be 360. So it's called a corollary because it's based on the previous theorem. So if it's based on a previous theorem, it's called a corollary. And this one's just specifically for a quadrilateral. 4 minus 2 is 2 times 180 is 360. So for any quadrilateral, the sum of the angles will be 360 degrees. So triangles are 180, quadrilaterals are 360. Do y'all remember exterior angles? If we take a polygon and extend the sides, we have exterior angles. So all of the exterior angles of a quadrilateral, which would be, let me mark them, this one, this one, this one, and this one, they would also add to be 360 degrees. So that one's kind of like a not really, I'm not going to say important. It is important, but it's not one that's commonly used. It's kind of less significance to us. Okay? Because we don't do a lot with exterior angles of a quadrilateral. We do a little bit with triangles, but not many with quadrilaterals. And that is the end of section 8.1. So basically just introducing you to some new terms like diagonal and then the interior angles theorem, n minus 2 times 180. So make sure you have that n minus 2 times 180 memorized, because if I remember correctly from that quiz that you're going to have at the end of the chapter, that will come into play quite a few times. Okay. All right, can we go on to section 8.2? Good. All right, so let me scroll up to the top. Please write down the definition to a parallelogram. I'm going to have trouble saying that word. Parallelogram. I had a professor in college, bless his heart, he could not say that word correctly. It was parallelogram. That'd be how my Jonah says it too. You can't say L's and R's. He said something cute the other day. Was driving to church or something. There was a little old lady walking her dog down the road. He goes, "Look at that little old lady walking her dog with her sunglasses on her head." It was so cute when he said little old lady. So I think pretty much for the rest of this chapter, we're going to focus on special quadrilaterals that are also known as parallelograms. Parallelograms. Some people say parallelograms. I've heard people say parallelograms. I don't care how you say it, same thing. Parallelogram, parallelogram, parallelograms. I don't know. People sound differently, but it's the same thing. So a parallelogram is a special quadrilateral. So how many sides is it going to have? 4. But the opposite sides are all parallel. Both pairs of the opposite sides are parallel. Now, what does it mean to be opposite sides if you're talking about sides of a polygon? What sides are opposite? The ones directly across from each other. They're non-adjacent. Okay? So the two pair that don't touch each other are parallel. So, for example, in this parallelogram, remember that we do indicate parallel by the same number of arrows? Right? So, for example, segment PQ is parallel to what segment? SR. And segment PS is parallel to what segment? QR. And how do we show parallel? Do y'all remember the symbol for parallel? That's perpendicular. Yeah, 2 lines. So PQ, and it's a segment, is parallel to SR, and PS is parallel to QR. So parallel uses the 2 lines. Also, the next theorem says not only are they parallel, but the opposite sides of a parallelogram are also congruent to each other. So notice how we have congruent. Remember, that's the equal sign with the squiggle line. Okay? Now, if we're saying they're congruent, we're supposed to use the thing. To say congruent, we're supposed to use the bar. Segments are congruent, measures are equal. So that means the length of PS equals the length of QR, and the length of PQ equals the length of A. Remember, if it's just length, you're talking about you have just the letters with no bar. So objects are congruent, measures are equal. So opposite sides are congruent. Let's scroll a little bit. Also, opposite angles are congruent. So there's lots of fun properties about parallelograms. So if I know the measure of angle P, I also know the measure of angle R. And if I know the measure of angle Q, then I know the measure of angle S. So opposite sides are parallel, opposite sides are congruent, and opposite angles are congruent. Those are the non-adjacent ones. I should say non-consecutive because they come after each other. All these big fancy geometry words. Y'all have really broadened your vocabulary just by taking this class. Did y'all know that? Y'all learn lots of good new words. So opposite angles are congruent. That's important. So what we can do, now that we know that opposite sides are parallel, opposite angles are congruent, and opposite sides are congruent, then we can find some missing values. So that's what we're going to basically spend the rest of the section there. I think we've got one more theorem to talk about. But basically the rest of the section will deal with finding missing sides and missing angles, or missing parts of sides and missing parts of angles. So this figure is a quadrilateral because it has 4 sides. It is also a what? How do you know it's a parallelogram? Because it shows that the opposite sides are parallel, doesn't it? If it doesn't show you those opposite sides are parallel, can you assume it's a parallelogram? No, it's just a regular quadrilateral. Okay? So unless it shows you that these opposite sides are parallel with those arrows, you cannot assume it's a parallelogram. Okay? But if it does show you that, then you know it is a parallelogram, so then you can use the parallelogram property. All right, do y'all want to work on finding the X or the Y first?
X.
Well, Y is pretty much given to you, right? It's an opposite angle from 65 degrees. So the measure of angle Y is what? 65 degrees. They're going to be the same. Opposite angles are congruent. Now how are we going to find X? You said X plus 4 equal to 12. Because if that whole side length is 12, then the X plus 4 has to equal 12 as well. Subtract your 4 and X equals what? 8. Do you put a degrees with that? No. If you're finding the length of the side, it does not have a degree. Easy, isn't it? Here's another one. It's only a little bit different. Y'all can do this without drawing the figure. I think so. Y'all can just work it out with me. Is this one a parallelogram? How do you know? Both sides are parallel according to the picture. They have arrows. Okay? So, let's find the angle measure first. How am I going to find the X? How do you think? Well, we know this entire angle is congruent to this entire angle, right? So you can say 3x equals 72. So if you're just finding what x is, we divide by 3. X equals how many degrees? 24 degrees. Okay? Any questions on how we found x? So how are we going to get y? Y minus 8 equals 15. How do I solve it? Add 8 and y equals what? 23. So any questions on how we got x and y? It really is that simple, y'all. You guys try these two. Number 1 is way too easy. You don't have to redraw the pictures, but if you need help reading something on there, let me know. All right, most of y'all look ready. Number 1 said find the length of FG and the measure of angle G. So FG is opposite from HE, and do we know the measure of HE? What's the measure of HE? 8. So did y'all get FG equals 8 also? And what about the measure of angle G? What's it going to be? How do you know it's 60 degrees? It's opposite from angle E. So raise your hand if you got 8 and 60 for number 1. That was just basically look at the picture and write it down. All right. Find x and y on number 2. So I'm going to do x first. So x is part of an angle measure. So how do I find what x is? Right, because it's opposite angles from the 50-degree angle. So you're going to say 2x equals 50, which means you divide by 2 and you get x equals what? 25 degrees. Raise your hand if you got 25 degrees for x. How do we get y? Right. I'm going to do it this way just because I haven't done one this way yet. So set 18 equal to y plus 3, and then you subtract 3, and what do you get? 15 equals y. Raise your hand if you got 15 for y. Raise your hand if you think this is easy. Y'all are afraid to say it's easy, aren't you? You're afraid it's going to get hard. Well, it's really not going to get that hard. We got one more theorem left. Don't write this down. This is just a remembering. Okay? Do y'all remember when parallel lines, one of our properties of parallel lines is if we have consecutive interior angles, they were supplementary. Right? So if we have parallelograms, they're made up of parallel lines, correct? And so if we have parallel lines, we have a lot of the same properties that parallel lines have. So if we have parallelograms, a lot of our parallel properties hold true. So if we had consecutive interior angles, they add to be 180 degrees. Okay? Well, guess what? If we have consecutive interior angles on a parallelogram, this line is parallel to this line. So that means PQ is like a transversal to that. These two are also going to be supplementary. Same thing with these two. So that means their sum is going to be what? 180. So opposites are the same. So notice they have y and y the same and x the same. But if they're consecutive, which means they come right beside each other, they will add to make 180. So opposites are congruent. Consecutives make 180. So that's the same thing where they are to go that way. And since these are parallel to each other, it also is true horizontally. These two will make 180. Because how many angles total do you have in a parallelogram? How many angles do you have? Only 4, because it's quadrilateral. Okay? So if they're opposites, they're congruent. If they're consecutive, they make 180. Pretty simple. So you don't even have to write this down. We can do this pretty much in our heads. This is a very elongated parallelogram, right? They're not marked, so I'm gonna mark them for you. We can't assume. I already told you that, didn't I? All right. So if it's a parallelogram, an angle D down here is 110 degrees, and we want to find the measure of BCD, which is angle C. What's C's relationship to D? Yeah, they're consecutive, which means are they congruent or supplementary? Supplementary. So that means together they make 180. Well, if D is 110 degrees, what does C have to be? 70 degrees. Does that make sense? So if they're consecutive, they equal 180. If they're opposite, then they are congruent. So what's the measure of angle B going to be? 110. What's the measure of angle A going to be? 70. Okay. And all together, they should add to be what? 360. Okay, another important theorem. I think this is our last one. I said that earlier and I lied. I'm sorry. One more important theorem for the day. Been a while since I've looked at this, so forgive me. It's been a year. So we talked about diagonals a while ago. They go through opposite corners of a polygon. So if we have a parallelogram quadrilateral, then the diagonals bisect each other. That's an important word. I've told you since the beginning of geometry that bisect is an important word. What does bisect mean? It splits it exactly in half, right? So if they bisect, it makes two congruent things. And since these are segmented, it intersects at the midpoints, right? So M is the midpoint of PR, and it's also the midpoint of QS. So that means QM is congruent to MS, and PM is congruent to MR. Okay? So we can't say that this one is congruent to this one, but we can say if they're on the same segment, they are congruent to each other. Okay? Important piece of information. So you don't even have to draw the picture, but just help me out here. Find the value of X in quadrilateral ABCD. I think that is actually the symbol for parallelogram. Mine just never looked like parallelograms. So that symbol tells me it's a parallelogram. So it has two diagonals. What do diagonals do inside of a parallelogram? Bisect each other. So if this one's 14, then all together from here to here equals what? 14. So how would I find X? That's right. I'd say 3x plus 2 equals 14. That's all you do. And then we subtract our 2. So 3x equals, and then divide by 3, and x equals 4. So any questions? Okay. Few more examples. We're going to find these 4 things with this picture. I'm going to give you a second to draw this picture. And this 110 degrees is all of angle J. That is the symbol for parallelogram. Except mine are just never straight. So it wants us to first find the length of segment NM. It has some diagonals that are bisecting, and they all intersect at point N right there. So what do you think NM is going to equal? It's going to equal 2 because it's going to be congruent to KN because it's a bisector. Right? The diagonals bisect each other. So NM will also be 2. Very good. All right, next wants me to find the measure of angle JML. Well, JML is the whole angle. Correct? JML is that whole angle. Well, what can I use to help me out with that? Consecutive, right? It's a consecutive angle with angle J, which means they are what? Supplementary. So, altogether, angle M is what? Well, together they make 180. If this whole angle is 110, this whole angle is what? 70. And JML is the whole entire angle, so that's what I'm finding there. Does that make sense? 70 degrees. Subtract it from 180 from 110. All right, so then it wants the measure of segment KM. Well, isn't KM this whole diagonal here? And we already found NM's part, right? And even if I hadn't found NM's part, I could still do it because I know their diagonals bisect each other, so I'd have to double the other one, right? So what's the length of that whole segment? 4. That diagonal is 4. Okay, and last they want the measure of KML, which is the little part of that angle. And I found the whole thing to be 70, right? Right? And the little part 40 degrees. Does that make sense? The whole thing is 70 because it's 180 minus 110. And then the little part's 40 degrees. Very good. Can y'all try those? Find C and D. You do not have to draw the picture unless it helps you. So all you need is the diagonal bisector. Pretty simple arithmetic here. And it doesn't matter which order you find them. All right, let's say I want to find C first. That means I take C plus 5 and set it equal to what? 11, because that diagonal is bisected, and it's going to be equal to 11. So I subtract 5, and C equals what? 6. And if I want to find D, I take D plus 4 and set it equal to what? And then I subtract 4, and D equals what? 10. Raise your hand if you got 6 and 10. Any questions about those? Any questions about anything today? All right, this is the end of section 8.2 and the end of our lesson for today. See you later, math nerds.